Hello, I'm Professor Cheban Acharya. In this video, I'll do the homework from section 3.1. The topics is measures of central tendency. That's the topics. These problems are from MyLab Math, and I put them in the PDF format. And I hope this video helps you to do the homework in MyLab Math. First question is find the sample mean. Uh, I want to point out that question number one and question number two, what's the difference between these two? Both has questions find the mean, find the mean. But you notice that it says find the sample mean, find the population mean. Okay? But idea is how to find the mean. That's the main question. But I want to just let you know that sample mean is for sample data set, and the symbol is x bar, and the population mean symbol is mu. You read as this as a x bar and this as a MEW, mu. Okay, just the name for that. And notice that the first questions, this data set, even the all together is called data set, called data set, and this is the sample data set. The second question has a population data set. Okay, and each numbers here in this data set is called data item. Okay, data item, also called observation. In other words, you have 1 2 3 4 5 observation here. In other words, 5 data item here. And let's talk about how to find the sample mean of the first question. It's usually how to find the mean, and I think everybody know that to find the mean you need to add all the data values or data points and divide by how many data are there. The full idea here is to find the mean. You add 5 plus 10 plus 15 plus 18 plus 17 divided by, there is 5 data, 1 2 3 4 5 divided by 5, and if you add all the data points, the sum of all data points is going to be 65 divided by 5, which is going to be 13. Therefore, use 13 as the mean. But since this is the sample mean, you have 13 here, 13 here, but the symbol for sample mean is x bar. Therefore, you pick this as answer for this question. Similarly, you do for question number 2, the population mean for this 1 2 3 4 5 6 data set gonna be 9. Therefore, you pick this answer. Notice that this mu here is for population mean symbol. And I want to point out something here in these questions. Since we call this as a data item, and these are called axes. Okay, this pretty much called axis. Okay, and in other words, this 4 is x1, x2 is 9, x3 is 3, x4 is 11, and so on, and x6 is 13. It doesn't matter. You could have 14 as x1 or 3 as x1, and anyone could be x1, anyone could be x2. But my point is, in this data set, these all data is called axes, and I use that in the future lesson. I use x1, x2, or axis. X here is pretty much data item, but since you have a bunch of axes, we have x1, x2, x3, and so on. It's just extra information. Okay. This question is pretty much looks like word problem here, and here there is a company, and this the amount here, the company and the dollar amount here. In other words, here this 73.9 is how much company A spent for advertising. Okay, for this is the money spent in commercial for advertising by 10 company, 1 2 3 4 5 and 5 10 company, and the question is asking for find the mean uh, amount is spent. But is that the uh, sample or population? What do you think? Of course, this doesn't include all the company. This might be a sample. Uh, if there is not mention, you can consider this data as a sample data. Okay, but it doesn't matter because mean is going to be the same thing. You're not using symbol here. You just write what's the mean is in this question. And idea is, as I mentioned before, you add all this numerical values and divide by 10 because there is 10 data items, right? That's how you do it. But I want to show you how to put this data in the calculator and how do you find the mean using calculator. And this is the calculator you're supposed to use for this class TI-84. You might have different version of the same calculator, but pretty much all of the calculator works same way. If I'm going to use this one, since this is in my computer, if you have something here, you don't have to worry about too much. If you want, you just clear it. This you have a blank window, and first I'm going to teach you how to put the data in the calculator. You're doing this in the future often, okay? Therefore, first thing you got to know is how do you put the data in the calculator. This is the data. You have a 10 data item here, and to put that data in the calculator, you start with start, click start, and click number 1. That gives you edit, and you see the column here L1 L. Some of you might have a data in the calculator. You can clear and you can put the data. Okay, now by default I want to put you guys this data in the calculator. Everything you're gonna have to put in under L1, one column L1. If I'm typing 73.9, that's the first data, and I press enter, and it goes to the CL12. That means you're putting second data in the first column. Okay, that is 63.2. 63.2. Press enter, and you put 56.6. 56.6. Enter. I'm gonna pause the video. I'll put the data and back with you. Okay, I put all the data in the calculator. This is my last data. 20 is 10th data here. You can see that, and that's what I put in the calculator. Now if you just leave it like that, just off, you turn off the calculator or just do second mode, whatever. If the calculator is blank, you already know that you have a data already stored in the L1 in the calculator. Therefore, to see it, you can just start. You just do start and number 1. You can see that's the data you already put it there. Now my point is, how do you find the mean? Okay, in the calculator, what you have to do is you go to the start back again. Okay, and you choose the calc option. You have to use this one var starts, not two var starts, one var starts. Since this is highlighted, press 1 so that you see one var start, and see this is blinking here. By default, this calculator takes the data from L1 by default. Since you put the data in L1, you don't have to do anything. But if you put the data in L2, you have to type L2 here, right? Since your data is in L1, you're good, but still you can type L1. How do you type L1? Look at here, under 1 you have L1. See L1 here? Therefore you pretty much press second and 1, you have L1. In other words, you're finding mean from those data that is in L1, and you press enter, you get that value. And if you notice that in this window, you have X bar is 39.66. That's the mean of the data, and you see the mean here, 39.66 is B. That's the answer. Okay, that's how you have to find the mean using calculator. All right. Okay, this is the mean, okay? But if you scroll down here, you'll find another value, and you see the MED, that's for median. Therefore also you'll find the median using calculator. And also you have another stuff you can use calculator to find it. It's called Q1, quartile, max, mean, all you can use to find the calculator. Standard deviation, we're going to use that often in the future section. Therefore this one word stat is very useful function in chapter 3. Question number 4. This is similar to question number 3, but you have different number. You see this different number than question number 3. Okay, but again, this is the uh, um, commercial uh, cost or advertising cost for the company, and the question is calculate the median. That's the question. And there is a two way to find the median. The one way you can use a calculator, and another way you can use by hand. Let me do this problem by using hand or without using calculator. Okay, first thing you have to do to find the median is you have to order the number. You put the number in order. It doesn't matter smallest to largest or largest to smallest. Let's order the number. Okay, let me pause the video and order by myself, and I'll be back. Okay, I ordered the data, and see that in this data set 20.7 is the smallest number, and the highest number is 70.2. This is the order data, and I put an increasing order. Now I'm trying to find what's the middle numbers of this data set. If you look at, there is 10 data. Obviously you can have a 10 data here, 1 2 3 4 5 here, and other 5 gonna be here, right? See, 1 2 3 4 5, 1 2 3 4 5. And in other words, there is two data that are in the middle. Look at these two data that are in the middle, because see, the 4 data is on the right of these two data, 1 2 3 4, and the 4 data is on the 4 data is on the left of these two data. Correct? Okay, here 1 2 3 4. You have in the middle there is two data, and the median is somewhere here. Median is here. Okay, median is here, and the median is halfway through 24 and 29. And to find the median, you have to find the average of 24 and 29. 24 plus 29 divided by 2, this gives you 53 divided by 2, that gives you 26.50. That's the median, and answer is A. This is done without using calculator. Let me show you how to do this in the calculator. Like before, I'm gonna put the data in the calculator. This all data. As you remember, I put the star here, number 1 here, and I can put in L1, L2, doesn't matter, whatever. Since I have already in L1, I can put in L1. If I didn't need this data, I can put in L1. Therefore, I want to erase all the data in L1. What I have to do is you just highlight L1 and just clear and enter, and everything is on the data is gone. Okay, highlighted L1, press clear and enter, then everything is gone. Now I can put the data in L1, or I can put it in L2, doesn't matter. Let's try putting in data in L2. Okay, let's put it there in L2. Again, you can put in L1 or L2, it doesn't matter. 70.7, enter, 63.2, enter. Let me pause the video and back again. Okay, and I put this data in L2 this time, and let's find the median. Okay, and again, to find the median, click start, and you select calc using this arrow button, calc, and select number 1 Boris stat. Select number 1. Now since your data is in L2, you have to type L2 here. Okay, since remember that for this question I put the data in L2. If I have to type L2, how do you type L2? You just put the second, click second, and 2 here. Under 2 you have L2, therefore press 2, you get L2. Let's enter, and you see that you'll find all this measure here, and there is other one we use in next section. There is this the mean, but we don't use the mean, we use median. Therefore there is no median here, therefore to see it you scroll down here, here, here. See MED med, that's for median. Okay, that's for median. Therefore median is going to be 26.5, what we found before. This is how we do median using calculator. Okay, question number 5. The professor has a recorded exam grade of 40 students in his class, but one of the grade is no longer readable. Remember that you can read the grade of one person. If the mean score of the exam was 82, 82 is mean of all exam score, including the non-readable grade as well. The mean of 39 readable score is 84. There's two mean here. 82 is the mean and 84 is the mean. 82 is a mean of 40 score. 84 is mean of 39 score. You know why? Because mean of 39 score is 84, because one is not readable. If you exclude not readable score, mean is 84. And let's think about this mean. 84 mean equals to sum of what? Sum of 39 score, a readable score, divided by 39. Correct? That's how you find the mean. Sum of 39 readable score divided by 39 is 84, which is the mean of those 39 score. If you multiply both sides by 39, what happens? You'll find sum of 39 readable score. What is sum of 39 score? Let me write down just 39 score, not readable, because of course 39 are readable score. You multiply 39 times 84, you get 3276. Okay, this number, we need this number. Okay, that is the sum of 39 score is this much. We find this from this equation. Now let's use 82. What is 82? 82 is a mean of what? 40 score. Therefore sum of 39 score plus the last score is not readable score, not readable score, divided by 40. Remember, 82 is the mean of all 40 score. Okay, and 82 must be sum of all 40 score divided by 40. Now you have to put this, the value of this sum of the 39 score from the previous part. 82 equals 3276 plus a not readable score, not readable score. Oh, can I put not readable score as an X? It's easy for me. Okay, not readable score as an X. This is X. Okay, this guy here, not readable score is, I put as an X. All right, divide plus divide by 40. Oh, that's what 82 equals. Now you multiply both sides by 40 to clear 40 in the denominator. Let's cancel. What is 40 times 82? 3280 equals 3276 plus x. That's what I'm looking for. X is not readable score, and the question is what's the value of unreadable score? That's the x. And how do you find the x? Subtract 3276, subtract 3276, just cancel. If you subtract 3280 from 32, you get a 4 equals to x. Therefore, in this question, what is not readable score? Your answer is was 4. Question number 6. The following data represents the pulse rate bit per minute of 9 students enrolled in the statistics course. Treat the 9 students as a population. This is the population that the question says. Okay, and you complete the following, part A to C, and determine the population mean pulse. Therefore, first question is looking for population mean, and again, this is the data. Either you can use a calculator, or if you add this all number and divide by a number of data, you get population mean, and this answer is going to be 75.8. Okay, I'm not going to do that. You know how to do the mean. That's fine. Okay, part B, determine the sample mean of the following two sample of sample size 3. Okay, it says size 3 in the sense that you have 3 data in the sample: prefectural pulse, Clarice pulse, and crystal pulse. This is pretty much prefectural pulse is 62, comma, Clarice pulse is 77, comma, crystal pulse is 75. And this is the sample number 1. And first question is find the sample mean of this sample data. This is going to be 71.3. You can find sample mean. Just add this 3 number divided by 3. Similarly, find sample 2 mean. Must be 76 for sample 2 mean. Okay, and that's how you find the sample 1 mean, and you find the sample 2 mean. Okay, now part C, determine if the mean of sample 1 and sample 2 overestimate or underestimate or equal the population mean. In the first question, remember that population mean is 75.8. Sample 1 mean is 71.3, which is lower than 75.1. Therefore, sample 1 underestimate the population mean. Under estimate. Why? Because this sample 1 mean is less than the population mean. Therefore, sample 1 mean underestimate the population mean. Likewise, sample 2 mean overestimate the population mean. That's how you solve the question number 6. Okay, number 7. If the distribution is skewed to the right, the graph looks like this. This is the right, skewed to the right distribution. The data here, this is the data line, and this point here corresponds to this point in the data is called mode. The median and mean position are going to be on the direction of the tail. Remember, this is the tail. Of course, this is the tail. This is the tail. This is the right tail is longer than the left tail. That's called skewed to the right. And the mean and mode are going to be on the direction of the tail. And mean is away from the mode in the direction of the tail, the longer direction here. Mean, the median is somewhere between mode and mode. This is the median. Okay, This is the median. And remember that because of tail, this mean gonna be always away from the median and mode on the direction of the tail. The mean must be here, not here. Of course, this is the mode. This point is the mode because of this highest frequency. Remember, this is the frequency. Highest frequency is mode, but the mean is always away from the mode and median. And the question is, what do you think? Is mode, median, mean? Which one is larger? Notice that mean is larger because if you go to the right, the data points becomes larger and larger. You can think about that. This is like say 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110 like that. Therefore, if you go to the right, the value of data gonna be bigger and bigger. Where mean is bigger than the median and mode is smaller than all of those. The answer must be, for this question, D is the answer. Okay, see, mean is greater than median and greater than mode. Mode is the smallest one. Question number 8. Here, if you read the question properly, and they give you mean test score is 77, median test score is 82. Okay, and the question is, what type of distribution most likely describe the shape of the test score? There are 3 types: skewed right, skewed left, and symmetric. And here, if you notice that this is the data here. Data here is pretty much score. The mean score is here. Let's say mean is here. Whatever. Okay. I put 3 points, just mean, mode, median. Okay, median score is 82. Therefore, let's say 82 is here. That's the median. And the mean is 77. 77. Listen. Mean is smaller here than median. Look at this question number 7. Mean is bigger than the median. Okay, mean is bigger than, and this is skewed to the right, and the opposite happens here. Since mean is smaller than the median, it must be skewed to the left. Okay, skewed to the left. Skew to the left. What if mean and median are the same? This is called symmetric. But here, now symmetric because mean is different than the median, and this is the skewed left. Number 9. Which measure of central tendency more representative of typical observation if the graph of the data is skewed to the left? If data is skewed, which central tendency is useful? That's the question. Remember that if data is skewed, doesn't matter which way, skewed data, the median is useful. Number 10. Which measure of central tendency may not exist for all the numerical set? That's the mode. Because some of the data set, there is possible that that data set might not have a mode. Okay, therefore data set might not exist mode. Okay, that's the question. Number 11. The measure of center, that is the value that occurs with the greatest frequency. The greatest frequency is mode. If something happens with the greatest frequency, that's the mode. Number 12. For large sporting event, the broadcaster sold 51 ad, and the total revenue going to be 169 million. What's the mean price per ad slot? Okay, there is total revenue 169 million from 51 ad. What's the average price of each ad? That's the mean price. The answer is 169 divided by 51 million. The answer, if you divide it, you get 3.3 million is the answer. Remember that I already have a million here, rounded to one decimal places, 3.3 million. Okay, number 13. Uh, the median for the given set of 6 order data value is 31.5. 31.5 is the median of this 6 order data value. Let me put it down here: 5, 12, 25, the missing, 41, 51. Okay, this is the 5 data value, but remember that this is already order. The median gonna be 31.5. Notice that there's 2 value that are in the middle. Okay, and 2 values are on the left of this 2 value, and 2 values here are on the right of this 2 value. The median is somewhere here. The median is here, and we're looking for what's the median of this, what's the missing value here equals to. Let's say this is x. Therefore the median gonna be 25 plus x divided by 2 equals to median of this data, which is 31.5. And we solve for x, which is missing value. Okay, to solve for x, you multiply by 2, this cancel. 25 plus x equals to 63. Okay, and subtract 25, the x equals to 38. Therefore the missing value is 38. The question 14: what does it mean if a statistics resistant? In other words, what do we mean by statistic resistance? Okay, pretty much the question actually to define statistics resistant, and the definition is if the extreme value means very large or very small, relative to the data, do not affect its value substantially. In other words, extreme value do not affect, that is called statistic resistant. Okay, number 15. The US Department of Housing and Urban Development uses the median to report the average price of the home in the United States. Why do you think HUD used the median? Remember that last time we say that median is used if the data is, okay, I'll go back here. Here, see, if data is skewed, we use the median, but here the price of the home is skewed what direction, right or left? And the answer is price of the home is skewed on the right. Therefore HUD uses the median because the data are skewed right. Number 16. The histogram of the set of data indicates that the distribution of the data is skewed to the right. Histogram says the data is skewed to the right. Then which measure of central tendency is likely to be larger? Is the mean or the median? Why? Okay, this is the question we answered before. Listen, if data is skewed to the right, the mean gonna be larger than the median. Okay, therefore in these questions, if data is skewed to the right, the mean gonna be larger. Okay, Why? Because extreme value in the right tail tends to pull the mean in the direction of the tail. In other words, the extreme value on the right pull the mean towards the direction of the tail. By the time mean gonna be larger. Okay, number 17. In this question, is mean is greater than the median or equal to? That's the question, or less. And notice that this data is skewed what? Is skewed left. Is skewed left. If data is skewed left, over here, let me say, if data is skewed left, the mean is smaller than the median. Median is larger. Okay? Therefore, in this case, the median is larger because skewed left. And notice that in this question, X bar is for mean and M for median in this particular question. Therefore, here X bar is smaller than median. In other words, median is larger when the data is skewed to the left. The answer is going to be part A. Okay? You see that? Mean is smaller than the median, M, because the histogram is skewed to the left. In this case, the data is skewed to the left. You notice that skewed to the left. This is the histogram of the data, which is skewed to the left. The histogram on the right represents the connection time in seconds on the internet provider. Determine which measure of center tendency better describe the center. Here, data is skewed. We always use the median. Therefore, answer is center of distribution, or it's called central measure of center. Measure of center. The same name for center of distribution. We use median because data is skewed to the left. That's all about homework from this section 3.1. I should say the end. Thank you for watching this homework video. This homework video. Bye. The median of the given 6 order data value is 50. What I'm saying is weird.